the idea is simple, and though I was busy in some kind of work, so I was not able to focus much about more inputs. But let me cover you some simple things which are like change in the collection or utils or even in the streams and the strings. So later I went and I saw that we had a discussion on the parallel streams in the past. The stream part is kind of covered. Those there are times when I talk about the compact string and all, but yeah, I really want to show you that is there any advantage or not, and what kind of utils we have available from like moving JDK8 forward. Okay, so till JDK8 everything sounds good, but I see that there are few powerful things which like came in JDK9 and then came into the later version also, like JDK11 also. So even though I'm talking of JDK11 and currently we are running on JDK15, but then it's fine. I mean, we can consider last LTS and everything is fine. Okay, so if I mean we have around 16-17 participants, and if you guys already know all these things, I am good to skip. So I am not sure that how many of us have studied about the unmodifiable collection, which came under JEP 269, if I'm not wrong. Let me check it out. So just 1 second. JEP 269. Yeah, so the detail will be available here. Okay, so it will clearly tell you about the convenience factory method for the collection. And what actually we have changed is that we have changed, I mean, most of the people discuss like kind of syntactical change or kind of very verbose thing changed into a small way. But then underlying changes are more than that. Okay, so if you are like on JDK8 and you have to create an unmodifiable set or you have to create an unmodifiable collection, the way generally we do it is what is on my screen. Okay, and anything wrong with this, or everything is fine in this, or it is just like I can reduce this code further, that we will discuss. But first of all, what is the use case of having an unmodifiable collection? Use case is simple, right? Collection is a very heavy duty work into the Java code. Most of the applications use collections very heavily. And definitely when I'm running a collection and I know that my underlying data is fixed and nothing is changing out, generally I want an unmodifiable collection, and it makes me completely like thread safe. I really don't have to worry much about the threads when the underlying collection is unmodifiable. Okay, and it holds good to have lot of places where the collection need to be unmodifiable. So before the JDK9 era, you generally have to like you have to add a lot of things into the set, and then from the old set you actually creates a new set. Okay, and that's a unmodifiable collection. And the thing is that, okay, I can show you this from let me see if because we were discussing with JSL, so let's see that how well JSL runs here. So if say like I am creating a list, and say like it's a string, and right, so I have created an empty list, and then I can add few elements into the list. People who are aware with JSL, they know what I am doing it, and people who are not aware with JSL, it's just an interactive cell which came into JDK9. I am running on the latest code of JDK11, which is 11 or 10. So JSL is just like running a calculator, or it's a REPL actually. People who are from the JavaScript side, they know REPLs very well. So I can really run anything. I really don't have to put semicolons and all, and I can use it. So here I just created a list, and you can see that I can add the things, and life is good, and I really don't have to do too much of sugar coating to print the list. I will just say list, and it can tell me what are the elements that are added into the list. And now if I want to create list one, and which I will go for the collection dot unmodifiable, right? So I will write, and you can see that the double tab will also work if you forgot. So I will say collections dot unmodifiable list, and inside this I can pass my old list, and I am good, right? So now list one is actually an unmodifiable version of list. Okay, so everything is looking good, and if you try to add now few elements into the list one, ideally it should not let you do. Okay, so you can see that it will tell you that it's an unsupported operation. Okay, I though even I don't agree with that word, like unsupported kind of operation, but yeah, it should have given much. It's fine. Even unsupported operation sounds good. So things are looking fine, but is it really a? Is it really? Yeah. So you can see that you cannot add element, but the thing is that, can I add element into the list? Let's check it out. Okay, so you can see that I can add element into the list, right? And now the new list value is ABCD. And how about the list one? And now the list one also got changed, right? So I said that list one is actually unmodifiable, but in the end it's just a pointer on the onto the list, right? So if I will change the underlying list, the list one will also get changed, which sounds okay and not okay in both the case. So why it is not okay? Because it's a unmodifiable in not the real sense, because we are just creating a unmodifiable wrapper on the top of a modifiable list. Okay, so I should say that it's not a unmodifiable list in a true sense. Okay, so I do can a lot of things where I will try to hide the list, and I will not let people modify the list, or list will not be visible to people, and then I can use the list one. But it comes with a lot of issues like this kind of thing. And the second issue which you can see here is that the code verbosity is very high. I mean, you have to write a lot of things to create an unmodifiable list. The number 3 point which you can see is it's kind of not a space friendly thing. Okay, so memory consumption is high here, because I really have to create extra wrapper, and inside the wrapper I need to put a list which is like the same old bread and butter. Okay, so JDK 9 came with something which you guys can directly change into if you are like on any ID. So you can just click here and you can say that change it with the unmodifiable list. So just think of this set, and now you can see I really don't have to put into anything, but okay, let's um, anything. Okay, let me do a set only. So I will create a string set only, and I will say set equal to set of, and whatever the element. Right, so it has created a set, and this set is modifiable or not. You can check it out. Set also have a value called add, and I will try to put something, and you can again see it's an unmodifiable operation, and there is no underlying thing which you can really modify. Okay, so you can see that we have only one element which is set, and it's actually unmodifiable. Whereas in the old thing, it is possible that I created a set, and then I have created an unmodifiable set, and I have actually changed a modifying or a mutated set into a unmodifiable set, right? So you can see my both the sides it is set. Okay. fine. That side, that idea is also good, but I can tell you that this code can create a lot of thread issues when you will really deal with the real life. So you need to be very careful when you are doing this kind of creation. Now, going into the source part of this, you can see that from where the unmodifiable set is coming. So unmodifiable set is coming from somewhere from this method, and you can see this is a method and which is returning you an unmodifiable set. And unmodifiable set is actually extending something called unmodifiable collection. Okay, so you are reaching somewhere onto the unmodifiable collection, right? And then definitely unmodifiable collection actually implements serializable. Now, do it's almost follow the same path for the other codes also. Let's check it out. What if I will convert this into off? Let's check it out off. Okay, yeah, I will definitely come into the implementation of off and what kind of things are available. But you can see off directly go to the immutable collections. Okay, so different class altogether to deal with. Okay, so don't think like inside we have done the same kind of code, and in place of you writing the code, actually JDK has put that code inside. Okay, so it is completely different way how it has been handled. Okay, I mean, that is the basic thing I want to tell you. And right, so this is kind of the detail, but now let's discuss about the Java doc or the API. So all the off, right? All the off, either it is a set or list or whatever it is, it provide you a very detailed method. Okay, so what it do actually, you can see that you can have a off on one element, or you can have off on two element and three element and four element, go, and 8 elements and 9, 10 elements. And after 10 elements, finally, we have a var arg, right? Where you can put like more than 10 elements if you want, 15 element, 20 element. So you can do that. So any clue that why we are not just providing one var arg, or like um, why this much of verbosity, like we are providing kind of 10 parameters and not just a var arg? Any idea?
For better performance.
uh, Performance point is very good. So what is the issue with the var arg? Okay, so sorry, because I am a VM guy, I will generally move on to the performance very fast. So what do you think is the performance issue with var arg?
Compile time versus runtime.
Okay, can you explain it in little more detail?
So var are completely evaluates during runtime, but whereas multiple argument one, the binding happens in the compile time.
Yes. So the point which you have made is completely fine, and this is good for almost all the time, rather than there are times when the JIT compiler can actually implement the var args, but generally, yes, your point is right. So var arg generally takes thing at the runtime, and it can delay the thing, and the memory consumption is actually dynamic when it do the allocation. Okay, so I am not sure that I have written something on the var. Yeah, so you can see like this is a small benchmarking done on the var arg, where in place of passing 4 arguments, I prefer to pass with the var arg. Okay, so I have just taken it from somewhere. And if you see the time consumption in the normal parameter or array or versus var arg, you can see the value. I hope my screen is visible, right? So you can see, right, like passing the normal 4 parameters, or creating an array of that and passing, or creating a var arg. Okay, so what I want to show you is that still after a lot of heat ups and all, the performance of var arg is almost kind of 4 to 5 times higher than the normal parameterized runs, right? So most of you have already said that. So this is the reason that why we have went into the verbosity of where we have like kind of we have, even if you are passing like 10 parameters, we are good to use those 10 parameters. But yeah, if you are definitely more than 10 parameters and all, then we have to do where. Okay, so this off method is available everywhere. It's into the set, and it's available in all kind of collection. Okay, so for more details, definitely you should look for JEP 269. Okay, so JEP 269 will definitely explain you that what is the goal of it and what is the non-goal of it. And we will have a lot of test cases also into the JDK source. So you can look into that also. Okay, so let me come out of JSL. Let me see if I have like, right, I have JDK source also, which will have a test. So it's okay. So I'll figure it out that where are the test lying for that, because I'm just seeing the hotspot test, not the JDK test. Should be somewhere. Okay, we'll figure it out. So any questions related to JEP 269? I mean, most of the people are aware with that. And you can see it went into the delivered state in JDK 9. That means either you are using JDK 9, which is now freezed out. So if you are using JDK 11, then only you can use the convenience factory method. And you can easily understand that why it is called factory method, because we generally use the factory pattern. And though we have Satish here who can explain more about the factory pattern, but do let me know if you are unaware of what is factory pattern. So generally what happens in a nutshell, I can explain you that why we generally use the factory pattern. Though I am from systems, I really don't know much into the detail. But when you have multiple implementation of thing, right? When you have multiple implementation of thing, and you kind of so I can do like a kind of runtime dispatch where I can say, okay, so I have a vehicle, and from the vehicle I can have car, truck, and this and that. And when I'm creating the instance of vehicle, I can give it to the instance of car or truck. But in factory pattern, actually I want to hide this detail. And any of these details implementations or the modification I really want to hide. So what I will do is that I will say that you have to create with a factory get instance, and I will write some kind of different logic. So I will say that, okay, if small vehicle return car, if big vehicle return truck, okay, if something else return this. So what happens that it will be a kind of it's a factory who is just giving you things as per your demand, and you really cannot see that what is hiding inside the factory. Okay, so JDK code itself use a lot of factory pattern. We use singleton, and you know, I mean, any source code use a lot of patterns, right? And in general, I say pattern is like a code word between me and you. So when I'll say that in place of actually explaining you how to write a singleton, I will just tell you that write the singleton pattern, and you should be good enough to write it. Okay, this is how the pattern came into the market. Okay, so
yeah, to be precise, Evo, to add to that, when you have a factory, you can say that it's all like pre-built, well-tested objects. That's what we need to consider. Whenever we can make things on our own, but if you go and get it from factory is specialized in doing it. So if you can get it from factory, you can see that, okay, it is all well-tested.
Yes, Satish, that's right. I mean, that is the way. Okay, so yeah, coming back on this, so you can see that all the things has been discussed here and dusted here. that in place of this, what else we can consider, like this we can consider all the other things, we can consider to writing from streams also. But why we have not considered any of these things, and we have went and wrote a new convenient factory collections, because of that it has explained everything, and then it has explained that why those arguments have been passed and how to enter the entries. So all the details has been explained. I generally read these documents not because these documents are the only source of truth, even the other document, but generally when I do the presentation, I know that I can copy paste these information and I can just put on my slide rather than too much worrying about who has written and what to written, and should I give the credit to the person or not. So that's why I generally prefer reading these documents. Okay. And you can see it has clearly said that unmodifiable collection avoid the need to make defense copies, right? And they are more amenable to parallel processing. Okay, so defense copy is something which there is a wiki page for that, and you must have understand that when you start modifying something, then you will start making copy. Oh no, let me save a copy for this and then I will modify this, right? This is not generally seen a pattern for the people who write like code from the scratch to the end, but generally kind of patches code, we do this kind of work. Okay, so be careful with something called defense copies. All right, so I will just look into the questions if there is any, and I will go to the next. Does it has to do something with the type eraser and the type arguments? Devesh has raised this question that it has to do something with the type argument. Devesh, the type argument is also discussed here, okay, in this document, and it say that the design is little bit similar to what it is like the type argument. Okay. Going forward, okay, this is the document which can explain you more details, and I think I have almost covered all the things. Okay, compact string is something again which I want to emphasize you, and it is very simple to use. That's why I have not written much of the detail. So we have actually changed the internal structure of the string in again I think in JDK 9, JDK 9, JDK 8. I'm not remembering, and though we have set a JVM argument that you can switch on and switch off the compact string. By default, it is switch on, right? So by default, compact string will be into the plus. Many times I emphasize like how you can see the switches if you want to. What you can do is that you can do a query on the Java and you can say print all the flags. And then say like I can grep compact, right? So it can if I land with version, it will terminate here only. Okay, no. Where? Oh, grep compact, no such file or directory. Why? Still nothing. Yeah, we have few details. So you can see the compact string is by default true, and it's a product feature, right? It's a PD feature. Okay, and these are kind of not related with the compact string. So I can switch it and switch off. And what actually it do is that the internal string used to use character array, which we have converted into the byte array. Okay. The idea was very simple. The idea was that, let me see if I have an example. Okay. So idea is that if you are like creating a string, right? You are creating a string and you are saying new string hello. Okay. So if you know the truth, then every character into the Java is actually 2 bytes. Why? Because 1 byte is not enough, because we handle the international characters also. But is it always that we write international characters? Like, I mean, almost like 99% of the software don't use the international character. So why to pay that much memory to those things which we generally don't use? So if you are using like something which belongs to the ASCII range, right? What it will do, it will convert that into 1 byte. Whereas if you are using something which is like Unicode 16, then definitely we will make it back to 2 byte. Okay. So in a simple example, I'm running this and I am just creating few of the strings, which is kind of a ASCII related strings. Okay. So first let's consider the performance, and then onto the JMC or some kind of thing. I can show you the memory efficiency also that is getting in. Okay. So by normal, you understood that it will be memory efficient to use the compact string because the 2 byte will be synced back to the 1 byte. Okay. But do it impact the performance? Let's check it out that first. So what I'll do is that modify add vim arguments, and it is for compact string I added already. Yeah. So no need to say plus because plus is by default. So let me apply this. Okay. And let me run this. I am dealing with quite a big number of strings, so give it some time to this. Okay, so I will just save this data for the future purpose. So you can see the number of string it has been created, and created a string of length this, which is almost took like 2395 millisecond. Okay, now let's disable the compact string, or disable or use some older version. Anything is fine. I mean, I can show you from both the ways. So I can say minus compact strings, good enough. Okay, so so don't trust on these benchmarking, because these I have emphasized many times into the past, they are not the real benchmarking, but it's good. I mean we are not really going to use this code into the production, so we are just fine to see what is going on, right? So you can see the I mean the performance is not that much getting impacted. Okay, so either you are using compact string or you are not using compact string. So if you will say like I will run this code some multiple times, so there will be a little bit of new if condition which will definitely come, which will be check that what is the encoding type, it is a ASCII or it is a UTF-16, and accordingly it will decide that. Okay, so performance wise, definitely you can see a bit higher in time. Okay, but a generation of a string will be almost taking almost the same time, nothing much, whereas the creating the string of big length is taking little bit of more time. But I can definitely assure you that if you will if the JIT will become hot, it will be quite comparable. It's not like it will take much higher time. Now right, so right now I have switched off the compact string, and I will show you how to get you the detail. Okay, I have a system.in.read, so it will hold the command line till I am not ending it. Just 1 second. We have the compact string off, right? Okay, and let's run this program, and I can see On the memory, there is no histogram. Let's refresh this. Okay. So I keep forgetting. So currently we have the compact testing off, right? And let me take a screenshot. I will not remember these data. So byte array still, because we are on JDK 11. Okay, but if I load the same code with JDK 8, you will see it's a character array. It's not B. Okay, if you want, I can do that for you. And almost the space we are giving for the byte string is like 2.98 GB, and we are giving the space to the string, right? So a string is again 2.24 GB. Okay, so let's see that can we reduce it with using compact string. Okay, so what I'll do is that I'll just come here and enter, and this process will finish. Go back to the edit configuration, and let's either say plus, or let's remove it off. Okay, because by default is plus. Now again I'll run the code, and we have seen the memory performance is almost equal. I mean, little bit performance is better only, but that's okay. I mean, we'll compare it comparable actually. And now come back to here. Okay, let it be open so that we can compare it. And let's load the second one. And we should go to the memory, then we should refresh the histogram, and let's see. Okay, I really don't know that we got some advantage or not. The base is 2.24 GB and the string is 2.24 GB too. Whereas the last data, yeah, you can see the base was 2.98 GB, right? Definitely a string will be fine, but you can see the byte array is now almost in place of 3 GB. It is taking you 2.2 GB. So giving you a benefit of kind of like 0.8 or say 1 GB on 4 GB is not a bad deal at all, right? And people who are working in the cloud environment, they can appreciate this very much, right? So I have not lost anything on the performance side. In fact, my normal run is saying the performance is better, and you have a good saving onto the memory side, right? So these things are possible if you are using compact string. And what I can do, a small task more for you is that let me try to do that also. Is it possible that I can switch on to JDK 8? Okay, this is like kind of JDK 8, and that's good enough. Yeah, someone requested to switch on to the presentation mode, but unfortunately we keep changing a lot of things. So now if I'll run this guy, it should probably use JDK 8. Oh, it's parsing some stuff. Oh, is it not possible that I should only bother about this code and I should not bother of this code?
No, you have to comment it.
Huh? No?
No.
You can run that code as a scratch file.
I can run that code as is. Okay, I want to show all these things. So anyway, let me just kind of good to use now. No, what? Okay.
Above, there is one question. Is compact string ported to JDK 8 or only available in Java 11?
Just what happens that as I grown old, I forget things. I believe that compact testing is a feature of Java 9. So I don't think so in Java 8 you can apply compact testing. right? So that I will get to know by adding the VM argument. And this guy is really in pain in Java 8. Okay, let it go through the pain. So, I mean, it should have printed some details, right? And I don't know if I'll start my JMC also in that same time. Like this guy will really see the hell here only. So this process is running on 291. That's perfectly fine. And this is insane. You can see. So the difference of JDK 8 and JDK 11. Do I am running any other process? No, I don't think so. No, this was the only thing. This guy like kind of lost only. I think I should reduce the bit numbers here. I mean the string generation. Okay, this much time I really don't have. Let me make it a little smaller to get it done. Any other process? No, no process is running now. Now my fan is also making sound. But anyway, I have reduced the value. Okay. The only idea was that I want to show you that it's a character array in JDK 8. For that, I get into this unnecessary mess. And sometimes we just believe that people are believing on you and we should leave things. Okay, so fine. You can see that in JDK 8 it's a character array. Don't compare the value because you know I literally have removed 1 0, so everything will look very smaller. Okay, but you can see I mean in JDK 8 the performance is like nowhere compared to JDK 11. Okay, not because of just one compact string but because of many things. And is JDK 8 support compact string? Definitely, as per my knowledge, no. And I am sure that if I'll add this VM argument, it will tell me that you are not doing good. Right, so it's not in JDK 8. Okay, I saw enhancement where someone have requested this to make it in JDK 8, but you know these are big changes, right? So these are big changes. Why? Because you can see where is the string class? Right, so you can see this is the character value and thousands of things has been changed. Basically, you can see the change in like index of method. There is a big change. And if I will load the same code with kind of JDK 11, you will not see that character array. Okay, you will see the byte array. Okay, so generally this is how it deals in JDK 8. Okay, so it has a good verbose implementation. That's good. I will switch back to JDK 11 for rest of the things. I'm just sorry that I'm not very comfortable with all these kind of things, so don't get tensed. Okay, you have to like kind of give me 2 minutes to do all those kind of things. Yeah, in JDK 11, if I'll open, I don't know, this has opened JDK 11 code. Yeah, looks like, yeah, you can see here it's a byte array value. Okay, and you can see like index of method, and here you can get into the detail that how they do all the encoding, right? So you can see that if is Latin, a lot of things, and all those kind of things. So Latin and UTF-8, UTF-16 comparison and all those kind of things, you can see the details here. So just on the outer boundary. Okay, now if no further questions, we will move on to the next thing. Let me just get a pause and see all the chat window. Uh, is compact string ported on JDK 8? No. Any good reason to migrate on Java 11? Another good reason to migrate? Yeah, yes, definitely. And who said that? Sanjay, that the fact is that string is the truth of the any real application. Okay, so we have seen most of the applications, like the good deployed applications, they have around like 30 to 35% of the total data which just comes from the string. Okay, and that's huge actually, right? So if your space is like kind of 1 GB, you are almost taking like 250 or 300 MB into the string. So any performance in a string is a very good thing to have it. There is something called compressed string also, right? Um, there is a lot of things actually in the string. Okay, so we have compression of a string, and we have something called that is called deduplication of the string. Okay, so I am not sure that when we started and in which JDK we started, but if you will search like deduplication of string JDK. Okay, string deduplication came in JDK 8, right? Where like you really don't create two copies of that, right? So first we used to create one copy into the uh, memory pool, and one we used to create into the heap, right? So somehow we are saving on all those kind of things. Okay, so a lot of things are there for the string. Okay, so a string, there are like a lot of people who keep working and try to enhance string as much as possible, so that the real application can directly get benefited with out of this. So now say like compact string, you are moving from JDK 8 to JDK 11, you really don't have to do anything. I mean, it is like on the shelf provided to you, you just have to enjoy the feature. Okay, so that's good. Yeah. Any questions? You can definitely see the JEP, the compact testing JEP. I really don't remember, but you can definitely go and search like this, and it will take you to 254, and all the details are involved into that. Okay, so anytime you are going into learning the details of this, I will tell you to go into this document first, and then you can definitely see the Stack Overflow and this and that and a lot of other things. Okay, so you can see like these are the documents written by Brian Gotts and Alex Sipley and Charlie, and those are like they are working in the JDK from the genesis of Java. So believe on their words. Okay, it will explain you the details, and you can see we have run spec JBB, which is like a performance analysis tool, right? On the which aspect JBB is actually it's a Java benchmarking, and it do everything. It will create an entry, it will create transaction. It just don't actually finally what you say, it roll outs everything in the end. You don't really write anything into the database or something like that. So it kinds of simulate a complete environment to run the Java code, and you can see those performance benchmarking are available to see the details. Okay. Moving to the next discussion for me. Okay, this is mostly known by most of the people, like, but you know, in the hash map, there are like a few things which has been changed into JDK 8 only. Even though lately I have seen some changes that has been done, but I am not really remembering. The thing is that hash map is very much in general used by people, and if you'll go into the internal structure of hash map, it's actually an array, and all array points to a linked list, right? So you can think like a bucket, and then you have a growth in a particular bucket, right? So when you are adding a value, okay, which point to the array it need to go depending upon the hash code, right? You have a default hash code. You can change the hash code by overriding the methods, and what will happen that say like after the so if you have a um, say like if your array is from 0 to 15, right? So in the hash code, something will be written like they will do some kind of calculation and modulus 16. So what will happen with the mod 16, we will have the value belongs to 0 to 15. Okay, so now say like it got a value, say 8. So what will happen on the 8th array element, I will start appending the linked list. Okay, so the linked list will grow. And if your hash code is written very beautifully, what will happen? You will have kind of a normal distribution across all the array elements. So none of your list will really go too long or too short. So that's good because hash map actually say O1 kind of performance. But if your list will really go long, then it will become like kind of ON, where N is the number of element into the list, right? So how to tackle that? We have seen that in JDK 8, they have converted the list into a tree. So I really need to see the code. It's a binary tree, and if the value, if the element value will go more than 16 into the list, then the list will automatically get converted into the tree. If you will give me 1 more minute, I can basically see. And I am sure that the details is written here also onto the top about the new change. Okay, and they use a binary. Maybe I need to go to the interface of this, but they use a binary tree to do that. And now what happens with the binary tree? You can understand that now your search in place of ON, where N is the number of elements into the list, it becomes again log N, because the tree search is much faster than the normal list search. Okay. And definitely hash map is in very much use, and hashing technique became so common now that hash map is kind of a de facto for most of the applications. Okay, I mean the collection that has been designed for most of the application, they select the hash map. Okay, so any advantage, again, just like the string, if we will add into the hash map, it will directly going to impact your application. What will happen if the element will get reduced again back to the 16? No, it will let it be the binary tree only. It will not get converted into the list back. Okay, and that value also you can find somewhere into the code. I think it is 16 or 12. I think more than 16 element. Okay. Okay, so these are the details which I want to discuss on the collection side, and there are more things actually which I plan to cover. Maybe I'll cover sometime later. One of the least discussed thing is process handle. I don't know how many of you have used process handle, but I know a lot of people actually, they keep dealing with they need kind of the Java running process ID, and they want to use into the some utility into the other thing, and they actually want to simulate this behavior with the Java code itself rather than writing a script or some other thing. So definitely you have like kind of JCMD and all available. If I am into the bin, yeah. So JCMD can also tell you all the Java running process. Like currently there is only one process running, which is JCMD itself. Is it true? Why Java mission control, it has not said that. Oh, Java mission control is running with a different JVM. That's why it has not told you. Okay, so these kind of details is available to you. But what you can do is that you can get these details from the code itself. Let me show you the process handle test. So you can see all the details. Okay, again, I have added a system.in.read so that I can get the console running there. So if you'll go ahead and run this is available in JDK 9 and onwards. So you can see it will tell you the PID of this particular code, and it will tell you the process is still alive. And I can also get the parent process of this, which is actually 1855. Can I confirm this with the command line? Yes, definitely I can confirm this. So ps minus ef, if I'll grep Java, oh no, great, Java is long thing. So let me grep onto the process ID. Right. So if I will see the 9280 process, you can definitely see that it is a sample which is we are running it. Okay. And how about the parent process of this, which is 1855? And that's a terminal which is running. So looks like terminal. Yeah, looks like the terminal. So this Java process is from the native process, which is the parent of that. Okay, so you can see all these details. So this is very handy. I know a lot of people write this kind of application where you really have to take the Java process and you have to attach with some other debugger or some other tool. You can use this kind of handy things. You really don't have to go and use JCMD or some kind of your own written script to do all these kind of things. Okay, so this was JCMD is a replacement of JPS. JCMD, that JPS also used to be the process lister only. I don't really remember now that. Do we have JPS now? No, we don't have. JPS used to do some more work rather than just listing the process. Okay, I'll get on you. Okay, this JPS, right? So we have a JPS. Let's see what this JPS do. So JPS also gives you the list of. JPS will give you the list of the Java process, and JCMD will let you attach with the process. Thanks a lot. I think I was telling about the JPS only, not the JCMD, right? So in the JCMD, you can attach with a Java process from the command line. So generally how we use the JCMD is we write the process ID and then I will attach the flight recorder with this. Okay, so this kind of things we generally use with the JCMD. I mean, I'm not doing it. So yeah, what you said is correct. JPS is the list up of the Java process. Okay, so the last thing which I want to cover is also very simple thing, which is single file source code. This change has also happened in JDK 11, where you really need to not run multiple commands to get your things done, right? So if say like I want to run hello world, I can just say Java hello world. Okay, I really don't have to. Okay, so I really don't have to say Java C and then generate a class file and then do a Java. So this is the one command, one line command that is available. You will think like, okay, this is just looking little fancy, but it is not actually, because the main use was to support the C banks, like writing one command into the script. So you can see that we have a test. Here what I want to run a script, and inside the script I want to use this Java code. So I can definitely say the hash exclamation of to the Java and the source file, and whatever the Java file, I can use this as it is. Okay, so now you are writing your utilities and you want to write some kind of Java piece of code, you can get the values from C banks. Okay, so C banks are, I think, supposed to be supported everywhere other than Windows. Okay, so the C banks is only possible if you have only one command line to get the things run, right? So that is what the Java is enough powerful to run it from the single command. Yeah, that's it I want to cover for today, Satish. You are good to start now. Any questions? Let me just go into that. If any questions, good time to ask now.
Yeah, Vaibhav, so for the list and tree set, right, in hash map, why not default it to tree set always rather than switching from list to tree after the size grows?
That your point is good. Let me see that if tree have some kind of overhead over the list. Mm, yeah, I really cannot think of much overhead, though even like 1-2 overheads will be definitely there. Okay.
Yeah,
Like
they
in
must have
person,
come up with some reason.
it must have come up with some reason, definitely. And
Yeah.
the value they have decided, that is also must have come up with some reason
Yeah.
why they have selected 16.
Mm-hmm.
Let me see into the source if that data is able, that information will not be available into the source. Better I will reach to some person who have done that. Okay,
Okay, cool.
let me check it
Thanks.
out then. Yeah, thank you.